Hello, welcome to class. In today's class, I'll be teaching you what the product rule is about under calculus, and as well, I'll be introducing the formula for product rule. Also, I have the following questions on the board. So we'll be practicing product rule using the following questions that we have on the board. So if you are struggling with product rule, this is the right video for you to watch, because in this video I will explain in details on how to understand the kind of questions that you should expect and that you can use product rule to solve. We have three major way of solving. Now, the first one we have is the product rule, we have the quotient rule, and we have the function of a function, which we also call the chain rule. Now, we also have the first principle, but generally for objective questions that you might come across, you can only come across questions under product rule, quotient rule, and function of a function. Now, when they give you a question under calculus and they say differentiate, so it's either it falls into the category of a product rule question, a quotient rule question, or a function of a function. And sometimes it can be interwoven. So let's talk about what the product rule is about. Now, the product rule, when we are given functions that are multiplying themselves, for example, if I have a polynomial function y equals to 2x and it is multiplying a trigonometric function, remember the word multiply. Multiplying a trigonometric function so much that I have y is equals to the product of a function and another function, then that is telling me that this kind of question I solve it using the product rule. So in case where I have questions like y equals to 2x over sine x, this is a different thing entirely, because this is not product of functions. So when I am looking for product rule, I first check the question. What does the question says? Does the question says is a product of two functions, or is it a division of two functions, or is it a function of a function? So I need to first categorize my question into product or quotient or function of a function. Is that understood? So let's go into the formula for product rule. Given y equals to uv, since we are saying functions are multiplying themselves, so given y equals to uv, or we say u of x multiplied by v of x, that is when two functions are multiplying each other, the product rule formula is given by dy over dx. That basically means that you are differentiating y with respect to x. So the formula is given by u, that is the function u is what we are writing first, multiplied by derivative of v with respect to x, then we have plus v, that is function v multiplied by derivative of what? U. We have du and over dx. So the formula for product rule is given by what? Dy over dx equals u dv dx plus v du dx. So by the time you start solving consistently, you'll be able to quickly remember the formula. So let's solve our questions using this formula for product rule. We have our first question on the board. So we have y equals to this, and also we have our formula for product rule on the board so that we can make reference to it. So when I look at my question, I have y equals to x plus 4 multiplied by x cubed plus 6x. So when I look at the question clearly, I will notice that two polynomial functions are multiplying themselves. Then what comes to my mind is, oh, I need to use product rule to solve. So what I do next is that I categorize them into which one is u and which one is my v. So obviously from here, I can say that the first one, which is x plus 4, let it be u, and the second one, let it be v. So our u will give us u is equals to x plus 4 then our v will give us what? X cubed plus 6x. Now, clearly from our formula, we notice that we add or we need to differentiate v with respect to x, and also we need to differentiate u with respect to x. So we need to do that since we know u and v. So du dx is what we want to find now. So du with respect to x, that is, you are differentiating u with respect to x. So how do we differentiate? So the way we differentiate is that you pick the power on this variable that we have here, x. There's a power here, x, on x, and that's what? 1. Now you multiply the power by the coefficient of x and deduct 1 from that power. So what I mean by that is 1 times x, then you subtract 1 from the power. So also here, if you look at this, 4 is a number. When you differentiate a number, it will give you 0. Now we have the second one, v. So the v dx will do the same thing. So that will be 3 times x, then deduct 1 from the power, 3 minus 1. So what do we have in this case? We have the power 1 on x here. What would I have? 1 is here, then 1 times 6. We have 1 times 6, then we subtract 1 from the power. We have 1 minus 1. So let's write out our answer. What we are going to have here is going to give us x raised to the power of 0, right? Because 1 minus 1 is 0, and x raised to the power 0 here is 1. So we can conclude that du dx is 1. Du dx is 1, comma, then dv dx, our dv, our dx, will give us 3x squared plus 6x raised to the power of 0. And 6x raised to the power 0, of course, is also 1. Then 1 times 6 will give us what? 6. So we could conclude that the answer to this here is 3x squared plus 6. Now we know u, we know v, we know du dx, and we know dv dx. So all we need to do is impute them into this formula. So what we are going to have is dy over dx will give us what? Following the formula, we have u first. You're writing u. The value for our u is what? X plus 4. We are going to have x plus 4. Then dv dx. From here, what's dv dx? This value that we have here, 3x squared plus what? 6 plus v. What's the value of v? V is this that we have here. Is on the board. We have x cubed plus what? 6x. You notice that I'm introducing a bracket. I'm doing that because it's going to be products. What is combining u and dv dx is a product, a multiplication sign. So that's why I'm introducing a bracket to demarcate them. So this is v. Du dx is this that I have here, which is what? 1. So if we conclude, we need not to open this bracket. So if we have to, maybe because our options was more simplified, right? But if it's a theory question, you could leave the answer like that. So the value of the y dx will give us what? X plus 4 into 3x squared plus 6. If I open up this bracket, or if I open up this bracket, I'm going to have what? X cubed plus what? 6x. We can as well open this bracket, but we can also leave this as our final answer. For our next question, we have y equals to x squared plus sine x. Now, if you observe, we have a trigonometric function in this particular one. So kindly check out the video on the derivative of trigonometric functions. So let's quickly solve this. So automatically from this question, we could say that u is x squared and v is sine x. So we need to differentiate u with respect to x, differentiate v with respect to x. So du dx, from our previous knowledge, you would remember that I said you multiply this 2 times x, then deduct 1 from the power. That's going to be 2 minus 1. Then we are going to have, now what is the derivative of sine x? So if you differentiate sine x, what will it give us? It's going to give us cos x. So we are going to have cos x. Now let's introduce it into our formula. We are going to have dy over dx is equals our u is x squared dv dx. Obviously from here dv dx is what? Cos x plus v from the body is sine x, then du dx, the last thing that we have here is going to give us 2x, because 2 minus 1 is 1, then we're going to have 2x. So when we introduce 2x here, so the final answer to this will give us x squared cos x, I can't multiply 2x times this x because this x is an angle. So what I could do is I have to bring it at the front as a coefficient. That will give me what? 2x sine x as our final answer. I could as well factorize the value of x outside. It all depends on our options. This is the third question. We have y equals to 3x squared minus 2x in brackets. That's a polynomial function multiplying a trigonometric function. How do we do this? Still the same process. You write out your u. Your u is 3x squared minus 2x. Then our v will give us what? Cos x. So we need to differentiate u and v. So the x will give us what? 2 times 3 is 6. Then when you deduct 1 from the power, you have 6x minus, when you differentiate this should give you 2 because 1 times 2 is 2, then 1 minus 1 is 0. X raised by 0 is 1. 1 times 2 is to give us 2. So the x will give us minus sine x. Minus sine x. When you differentiate cos x, it will give you minus sine x. So we have dy dx in the formula. You have u. What's our u? 3x squared minus 2x. Then the v dx is minus sine x. I have minus sine x plus, what's my v? The value of my v is what? Cos x du dx. Du dx is this 6x minus 2. 6x minus 2. So we are going to have, now if you look at this clearly, I have a minus sign here. I need to bring it to the front. So what I could do is minus into 3x squared minus 2x, then the sine x, still write your sine x here. You're going to have plus. Now look at this. This is a polynomial. You have to bring it as a coefficient. So that will be 6x minus 2 cos x. So this is our final answer. In the fourth question, you notice that the second function is a logarithmic function. So we will still follow the same process and we'll learn how to differentiate a logarithmic function. So u will give us x squared plus 1, then our v will be what? Ln x squared minus 1. So let's differentiate u with respect to x. The x will give us what? 2x, right? Because if you differentiate 1 to give you 0, then the x. Now if you want to differentiate a logarithmic function, it's actually very simple. So what you do is you would differentiate the value that you have in the bracket. So if we differentiate these things in the bracket, it will give us 2x, obviously, because 2 times x is 2x, right? If you differentiate minus 1 is 0. So after you differentiate it, you write the answer, that is 2x, then over this total thing that you have here, that's x minus 1. For example, if you're asked to differentiate ln x 3x squared plus 2x minus 1. So the derivative of this will be that differentiate everything. That will give us what? 6x plus 2, right? Then you have over this particular question 3x squared plus 2x minus 1. You just differentiate it. So this is the y dx. That's how to differentiate a logarithmic function. Now we can introduce our answer into the formula. So we have dy dx will give us u. Our u from the question is what? X squared plus 1. Then dv dx is this that we have here, 2x over x squared minus 1. Then plus, now v, our v is ln x squared minus 1. Then du dx is what? 2. We have 2x in bracket. So from here we could see how to manipulate or maybe cancel out things. But if you look at this, we have difference of 2 squared, but in this case this is not difference of 2 squared. There's nothing we can factorize or simplify this. We just leave that as the final answer there. Then we would have 2x into x squared plus 1, then all over x squared minus 1, then plus, this is a function, you cannot multiply this inside this, right? You have to put it at the back. So we are going to have 2x ln x squared minus 1. So you could as well factorize 2x outside, maybe for your final answer. It all depends. So this will be our answer to the derivative of this question. For our last question, we have this. If you also observe, we have a different kind of function, and here we have an exponential function. So our u will give us x squared plus x, then the v will give us what? E raised to the power of 4x, right? So let's find the u dx. So the u over the x, if we differentiate this, that will be 2 times x, that's 2x, 2 minus 1 will still give us 1. When we differentiate x, we have 1. Now, how do we differentiate an exponential function? So you just differentiate the power, then the answer that you have multiplied by the coefficient. So what that basically means is by differentiate this, I'm going to have 4 and multiplied by this, multiplied by the question back, you have 4 e raised to the power of 4. So if we have e raised to the power of 9x, the answer is what? The derivative of this will give us what? 9 e raised to the power of 9x. So let's introduce our values into our formula. So the y over the x will give us what? Our u is this, x squared plus x. The v dx is this, 4e raised to the power of 4x. And then plus v, our v is e raised to the power of 4x. Then the u dx is 2x plus 1. If we observe, e raised to the power of 4x is common, we could factorize. So e raised to the power of 4x, if we remove that outside, then we'll have 4 times this left. So if I open the bracket, that will be 4x squared plus 4x. Then if I remove e raised to the power of 4x outside already for this other side, plus we'll have to open this bracket to still give us what? 2x plus 1. So finally, 4x plus 2x is the last thing that we need to solve. We have 4x squared plus 6x plus 1 as our final answer. Now, the fact about product rule is that before you can decide to use product rule, endeavor to be sure that the question that you are given is a product of two functions. So it could be polynomial and a logarithmic function, it could be polynomial and a trigonometric function, or even an exponential function. So make sure that it's a product of two functions, then you can solve using product rule. But if it's not a product of two functions, then product rule is not applicable.